This is our last video in our U substitution series. We're going to do more examples and talk about how you decide which one of the three versions, essentially, of U substitution that maybe should be what you're going for. So I have the three possibilities in what we're calling step 4, which is the goal of the substitute and simplify step. Remember, is to get one of these three, which is u raised to a power, but that power is not -1, or 1 over u, which is equivalent to u to the -1 power, or e to the u. So remember, that's our goal in our substitute and simplify step. So let's try a few examples. Which one was that? U to a power where that power is not -1. Well, I have u to the 1/2. That's certainly not -1. All right, so this first one, first thing I might want to do is rewrite that square root using my rational exponents for radicals, and write it that way. And so in step 1 in U substitution, which is always choose your u, again, we want to think about inside, thinking about getting our u raised to a power. Well, I have a power here, I have a 1/2, so perhaps I want to choose what's inside that power. And remember, we also want to keep in mind how we choose our u, that its derivative, or something very, very close to it, is also there in the problem. And I look at that real quick and I go, ooh, 6x plus, yep, I see that in the problem. Du over dx. So the derivative of 3x squared is 6x, plus the derivative of e to the x is e to the x, times the derivative of the exponent, but that's just 1, right? So the derivative of e to the x is just e to the x. Step 3, solve for dx. So I'm going to multiply both sides by dx. And dx over dx is 1. And then last but not least, I'm going to divide both sides by 6x plus e to the x. So I get du over 6x plus e to the x is dx. So there we go. So I've got everything circled or put in a rectangle that's going to be replaced. Anything that is not in a rectangle does not get replaced. Oops, I forgot my plus sign in there. Okay, and remember, this is my u, so that gets replaced, and it's to the 1/2 power, and then I replace my dx with du over 6x plus e to the x, and so that was start of step 4. 6x plus e to the x, I have 1 in a numerator, 1 in a denominator, so that reduces to a simplest term of 1. And so that leaves me with u to the 1/2 du. So let's see. So I'm going to use my power rule here. And 1/2 plus 1 is 3/2, so 1 divided by 3/2 is the same as multiplying by 2/3. U to the 3/2 plus c, and last but not least is my substitute back again, right? So I'm going to take out u and replace it with 3x squared plus e to the x. So my u got replaced. So I'm back to my original original variable. Okay. So here in the process of rewriting my radical as a rational exponent, I could see that I had an inside, which was 3x squared plus e to the x, and a quick inspection noted that its derivative was 6x plus e to the x. That's perfect. That's exactly what I'm looking for in my u. Okay. All right, now this one, I don't have a power, but if I wanted to rewrite that, I don't know what there came from. If you're preferring, you can take that all to the negative first power. In either case, right, from doing our ones that turned into logarithms, we saw if we had something in the denominator and it was not raised all to an exponent, then that was going to be our u. Or if we do raise that all to the negative first power, we can see we have an inside. So that is my first step, is choose my u. So u is going to be 1 plus e to the x. And I note that a quick derivative in my head, derivative of 1 plus e to the x is just going to be e to the x. Right, so this is going to be 0 plus e to the x, or just e to the x. So here's where I'm going to solve for dx. So multiply both sides. That's a 1. Du equals e to the x dx. Divide. So du over e to the x is equal to dx. And so that's what I'm going to replace dx with. So again, anything that doesn't have a circle or square around it stays. And then anything that does have a circle or square gets replaced. Right? So that gets replaced, and that gets replaced. But now we're going to clean up. E to the x over e to the x is 1. So this was step 4. So this is u to the negative 1 du, which, if we go back to our first slide, that antiderivative is ln of u plus c. And then step 6 is I replace u with 1 plus e to the x. Right? Oops, that should be right there. And I'm done. Okay. So if you have something in a denominator, that's a good candidate for your u. Or if you want to bring it up out of the denominator, the whole thing needs to be raised to the negative first power. And then that gives you a feel for an inside, right, for the power rule, extended power rule. So I'm going to do a little rewriting here. And I'm going to bring this denominator up and change the exponent to a negative. So again, I have something raised to a power, which gives me an inside, which tells me, helps me see what I'm going to choose for u. And also, its derivative is also in the problem. And we'll see that in just a moment. So we're going to choose u to be e to the x plus e to the negative x. So its derivative is, derivative of e to the x is e to the x, plus the derivative of e to the negative x is e to the negative x times negative 1, right? The derivative of the exponent is negative 1. So this is, in fact, e to the x minus e to the negative x. Aha! See, that's what I was saying. Its derivative is there in the problem. So now I'm going to solve for dx. By multiplying both sides by dx. And then finally, to isolate dx, I'm going to divide both sides by e to the x minus e to the negative x. That's 1. And then du over e to the x minus e to the negative x is dx. And so now I have what I'm going to substitute dx for. Okay. Again, anything that doesn't have a circle or a square around it or highlighted, if you're using colored highlighters, stays. And then anything that does have a circle or a square around it gets replaced. And I can't forget my negative 2 there. And simplify. So this was step 4, which is substitute and simplify. So I have an e to the x minus e to the negative x in a numerator and 1 in the denominator, so that makes a 1. So this is 2 u to the negative second du when all the dust settles. And so now I'm ready to integrate. Antiderivative of u to the negative second is u to the negative second plus 1 divided by 1 over negative 2 plus 1. So this is 2 times, let's see, negative 2 plus 1 is negative, so negative u to the negative 1 plus c. So that's negative 2 times 1 over u plus c. And so last thing is I'm going to substitute out the u for e to the x plus e to the negative x. And don't forget your plus c. And one last one. All right. So right, my first instinct is, oh, well, let's bring that up, or we try to look and see that this might be my u, right? So let's work on that. Let's use that. So I'm going to choose u to be 1 plus e to the negative 3x. And du dx is equal to 0 plus e to the negative 3x times the derivative of the exponent. So now I'm a little concerned because I don't see another e to the negative 3x in the problem. But let's just see how things go. Right, multiply both sides by dx. That's a 1. And then divide. And that's what I'll substitute. All right, so remember, step 4, our goal is to not only substitute, but also simplify. So 1 plus e to the negative 3x, that's my u to the negative first power, and then dx is replaced with du over negative 3e to the negative 3x. Ooh, but there's no e to the negative 3x to cancel. So I'm kind of stuck, because now if I try to simplify this, well, I do get 3 over negative 3, that's negative 1. U to the negative 1 du over e to the negative 3x. That doesn't simplify with anything. So I have a problem here because I've got a u and an x in the same problem. What else can I try? Well, let's try a little bit of algebra first. Let's see. One thing I want to know is that e to the negative 3x is basically 1 over e to the positive 3x. But then we've got a fraction inside of a fraction, which we don't like. So how do we fix that? Well, let's see. I've got 3 over 1 plus 1 over e to the 3x. Well, if I multiply this denominator by e to the 3x, and I multiply the numerator by e to the 3x, that's effectively multiplying by 1. So I haven't changed the value of whatever this rational expression is. But what happens when I do that? I get 3e to the 3x over, and then we distribute e to the 3x plus 1. Okay. So let's do that. Let's replace Let's try that. Now, in this new format, I'm going to use that for my u. Oops. Got a little carried away there. 3x plus 1. Then that derivative is 3e to the 3x, right? Because the derivative of e to the 3x is e to the 3x times the derivative of 3x. So that's where that 3 comes from. And then plus 0. So then du over dx, I'm going to solve for dx. So I'll multiply both sides by dx. Then divide both sides by e to the 3x. And that's what I get, right? Okay, so let's see how that works. So the e to the 3x plus 1 is my u. Dx gets replaced with du over 3e to the 3x. Aha! E to the 3x over 3e to the 3x is 1. And so when I clean that up, I simplify. I get 1 over u du. Yay, that I can integrate. And then last but not least, I'm going to substitute back in for my variable. Substitute out u and substitute back in e to the 3x plus 1. And e to the 3x plus 1 is always positive, so you can leave off the absolute values if you want, but it's not wrong to leave them in. There we go. So I had to do a little bit of manipulating first in order to get this one to work, but it finally did.